The main resource for this material is the open source Analytical Chemistry textbook by David Harvey. The material that we're going to be discussing here is contained in Chapter 4. We're going to mention some statistical terms. The mean is the average of a set of values. We simply add up all of the values and divide by the total number of values. The median is the midpoint of a set of values. And we're going to talk about different statistics, whether or not they apply to a population or do they apply to a sample. In general, sample statistics apply when you have less than about 20 replicate measurements. The true value or the true mean is the known value for the population, and the observed mean is simply the value that was observed, the mean value of the sample set. Let's start by determining the mean and the median of a set of values. Suppose we had the following set of masses of a sample of pennies, and we wanted to know the mean and the median. We are going to do this both longhand and discuss the Excel functions. For the mean, we can sum up all of our values, and if we found the sum of all of these values, it would be equal 21.821 grams. So we can calculate the mean, or X bar, as 21.821 grams divided by the number of measurements, which is 7, and this comes out to be 3.117 grams. We can also determine the mean via the Excel function, and the function in Excel is average, and then we specify our cell values that contain our data. Okay, for the median, to determine the median value longhand, we first place all these values in order, either ascending or descending, it doesn't matter. Okay, if we did that, this would be our result. And our median value, since these are 7 values, would be the 4th item. So we look to the 4th item, 1, 2, 3, 4. Okay, our median would be 3.107 grams. That's the middle value. If we had a even number of values, we would look at the 2 center values and take the average as the median. For Excel, the Excel function is simply median, and we specify the range of cells. We can express accuracy many different ways. The most common is absolute error or percent relative error. The absolute error is the measured mean minus the true value. And note, this has a sign associated with it, so that if you're underestimating the true value, the deviation is going to be negative. If you overestimate the true value, the deviation is going to be positive. The percent relative error expresses the error as a percentage of the true value, and this is often more useful in making comparisons. For example, the same absolute error is going to result in a much smaller percent relative error when the true value is large. we need to be careful to discriminate between accuracy and precision. Accuracy is the degree of agreement between the measured value and whatever the accepted true value is. The true value is seldom known, but often we have a gentleman's agreement as to what we can accept as the true value. Precision is the degree of agreement between replicate measurements of the same quantity. It has to do with repeatability. And these items are all measures of precision. Analytical chemists would argue that you cannot have accuracy without good precision. If we look at this third target, the average of these results is essentially meaningless. We need to have precision in order to have accuracy. However, we can have precision without accuracy. In the second target, we see that the measurements are precise, but they're not accurate. This is obviously where we want to be, high precision and accuracy. Determinate errors are systematic errors, or they're constant errors. They should be avoided if possible, and if we cannot avoid these errors, we want to be able to correct for them. And we'll talk about how we can correct for things like volume readings using burettes a little bit later in the semester. But determinate errors are systematic, they should be avoided, or we can correct the data afterwards for it. Indeterminate errors are accidental or random errors. There are small differences in successive measurements. They tend to have a random distribution, and they follow the laws of probability. A collection of many replicate measurements with indeterminate errors result in a normal distribution or a Gaussian curve.